Hello world. Today we're going to talk about a new innovation from my company, Bonaparte Investment Group, called Bonaparte AI Blockchain, where we use the AI technology to explain how blockchain works. And blockchain become to be big in the world, big innovation. And now with the emerging AI, so I thought we can put them together and have a new simulation how this is work using the AI technology to demonstrate how blockchain work. And machine learning, we're going to use the machine learning in the AI technology. Blockchain has a multiple stops, keys, transaction hash, block, and blockchain, and spending. And I'm going to go through this simulation to explain to you how blockchain works. And so when you go to, if you are investing in Bitcoin or Ethereum or any coin, you make transaction, but you didn't know behind the scene how the blockchain works. Now I'm going to explain to you how that works and using the AI technology. Again, we're going to have six stops. We start with the key. Every person, when you change the blockchain, you should have the system initiate for you a private key. Now, the private key translated to a public key. So if you change your, like if you put a key, for example, 1, 2, 3, 7, 7, 8, 9, if that's your private key, no problem. Immediately, a new public key emerge for you. People can see your private key, but they cannot see your public key, private key. The private key will be only for you, but the public key will be everybody, all the nodes in the blockchain. After you do a key, obviously you join the blockchain or Bitcoin or Ethereum because you want to make some transaction with your peers. So, for example, Bob sent $100 to Alice. That's your private key. This is a signature. And then that's a public key and then signature. If somebody tried to cheat the system and put like Bob sent $10 to Alice, in this case, sign, become to be red here. So that means this is not, you change the transaction, but if you put 100 here and sign, boom, the transaction is verified. This is the right transaction. So in our system, in the blockchain system, you cannot cheat on a transaction. After you make a transaction, you need to the system initiate something called hash. For example, if there is a transaction, Joseph sent 10 Ether. I'm going to use Ether today to Sarah. Well, then this message or this transaction will generate a hash. Every transaction, every message in the system will immediately create a hash. The hash become to be going to be a block. After you have the hash, become to be a block. What is that a block? There are four things to know about the block. It's a block number. We start with 1, 2, 3, and on. You go to cryptographic keys for the block, and then you go to data, and then you go to the hash. Notice the hash is 0, 0, 0, start with 4 zeros. Now, Joseph sent 1 Ether to Sophia, for example. If you mine it, then you see here the hash. If you mine it, now there is no zeros here, but if you mine the hash, then you're gonna have 1, 2, 3, 4 zeros. So that means this is a good hash. This transaction is good. You also sent 1 Ether to Sophia, and it's mined. That means this block is absolutely correct. After you have the block finished, you go to something called a blockchain. And we talk a lot about the blockchain. A blockchain is used in war and armies now, supply chain, inventory, also the cryptographic, cryptocurrency, metaverse also use a lot of coins, and computer games use a lot of coins. So they use also blockchain. So what is that blockchain? Well, a blockchain is blocks with a chain, like a block going to the next block. So for example, block 1, where is the chain coming? Block 1 has previous hash and a new hash. The previous hash was zeros because this is block 1. Only block 1 will start with zeros hash, previous hash. But then when you have a transaction, it become to be give you a hash, and the hash become to be a previous hash for block 2. On block 2 after a mine will have a hash, and then the hash of block 2 going to be a previous hash for block 3, and block 4, and on and on and on. Now let's assume somebody want to change, one of the people on the blockchain want to change the data and said, Joseph sent 50 Ether to Josephine. Okay, in this case, the block 4 become to be read and 5 become to be read. Why? 1, 2, 3, there is no changes, it's still already mined. But if you change something in 4, you have to mine it, and then you get a new hash number. Notice the previous hash number for 4 is still the same, like this previous hash, 000 B90, B90. Now, when you have a change in a fourth block, you get, and you mine it, you get a new hash, and the new hash become to be here, the new hash, get a new hash here, and then you mine it, and the fifth block also become to be mined, and then you have a new set of a blockchain. But notice here, if you change a message in the first blockchain or the second, let's do the first, for example, Joseph sent 9 Ether to Bob, then you have to mine the first, the second, the third, the fourth, and the fifth. So you have to mine all the blocks. But if you change only the last one or last 2, then you change only the last ones that you change. That's a blockchain. Now, we have a cryptocurrency since 1984, and Bitcoin was not the first one. But none of them work because it has a problem called double spending. In 2008, Bitcoin solved, Satoshi solved this problem. Satoshi is a name of unknown person. We didn't know, there is no person called Satoshi, but somebody sent an email peer-to-peer that he or she said that she can solve the double spending, he or she can solve the double spending, and here is the way to do it. They use the democracy to solve it. Suppose you have a block, node A is a person in node A, node B, and node C. All of these have the same blockchain, exactly the same. John sent to Terry, John to Sophia, John to Olivia, the same, every block the same. But now the system will go on and accept one of these blockchains. Now, let's assume the person in node B changed and said $10 from wallet from John, or 1,000, a wallet from John to John, and then approve that, and then mine the second one, and on and on. But node A and B did not change. Then the system will do a double spending check. What is a double spending check? Double spending check, that means we'll take the block that most popular. So what we have here, it's very interesting. Node A has a block that's different than node B, but node C block is very similar to node A block. That means we have a popular node A and C, they're similar, that's a popular block, but node B has a block that is not similar to A and B. So what the system is going to take, democratization, that means we'll take the block are the most popular in the system. So that's pretty much how the become to be a blockchain. That means that the most popular block become to be accepted and go on next and next and next and next. This is pretty much what we call it, the Bonaparte AI blockchain. We explain how you start with the key, transaction, hash, block, blockchain, and double spending. I hope you enjoy it, and now you understand how blockchain work behind the scene using the AI technology and machine learning. If you like our product, if you have any comments, please go to my email, joseph.bonaparte@cudenver.edu. You can click here and email me, and I'm happy to help you. Thank you so much, and I hope you enjoy the video. Thank you.